Alright, today we're going to be working on circles again, but we're going to start working on circles in a coordinate plane. So I want to make sure we understand really what a circle is. So take some time right now, pause the video, and write down in your own words, what is a circle? You guys have talked about circles since you were little kids, so what is a circle? Go ahead and pause the video. Now that you've written in your own words what a circle is, let's go ahead and write down what the actual definition of a circle is. You may have said that circles are round, or there's no edges, there's no angles. If you cut it in half, it's the same on both sides, or it's symmetrical. The actual definition of a circle is going to be important in order to write the equation of a circle. So the definition of a circle is the set of all points in a plane that are equidistant from a given point called the center of the circle. So let's pick this apart a little bit. The set of all points in a plane. In a plane meaning we're talking about two-dimensional and on a piece of paper. So all points in a plane that are equidistant. Equidistant meaning same distance from a given point called the center. So in theory, if I wanted to take a point and I wanted all the points that were this distance, I could swivel this around. And if I swivel that around, that'll make a circle, and that would fit the definition of a circle. So now I want to use this to write the equation of the circle in a coordinate plane. Well, when I look at this, we have to worry about the center. Center is going to be important. So the center of this circle is 0, 0. So center is 0, 0. Now the other key part is that they are equidistant. Well, how far are all the points from the center? Well, you could look at any of these points, but that'd be kind of hard to find the distance. There's a few points that would make it easy. If I look at this point, or this point, or that point, that's easy to find. We can count the distance there. Okay? So the distance from the center to any point on the circle, in this case, will be 4. In other words, the radius is 4. Now, we want to write an equation that relates any x comma y, any ordered pair, to the center to make this circle, because it's an infinite number of points. So if we consider this, if we look at maybe this point over here, x comma y, we don't know what it is. The distance from the center to that point is 4. So let's think about the distance formula. Distance is equal to the square root of our change in x, x1 minus x2 squared, plus y1 minus y2 squared. Well, that means our distance, we know, is 4. The distance between those 2 points is 4. The square root of, well, this point we're just going to use x comma y. This point is 0, 0. So x minus 0 squared plus y minus 0 squared. And if I simplify this, I get the square root of x squared plus y squared. Now we're not going to write an equation with a radical in it. We want to write it without the radical. So to get rid of this square root, I can square both sides. I get 16 is equal to x squared plus y squared. How you're going to typically see me write it is x squared plus y squared equals 16. We'll write our x's first, then our y's, and then our constant. So this distance was 4, that was our radius. So the distance between 0, 0 and x comma y, any point on the circle, is 4, and we can write this equation. Now we want to use this knowledge to then write an equation for any circle that has a center at 0, 0 and a radius of r. Well, if you think about that, if we were to graph that, the center is 0, 0. The radius, this distance is r. I have no idea what it really is, but if I swivel that around, every point that's a distance r from the point 0, 0, the center, will form this circle. So if we look at something similar using the distance formula, now instead of 4, our radius is just r, square root of x minus 0 squared plus y minus 0 squared, or r is equal to the square root of x squared plus y squared. And again, I'm not going to write the radical in my final answer. I'm going to square both sides to get r squared is equal to x squared plus y squared. And I'm going to rewrite it again with x squared plus y squared equals r squared. Okay, so this is your equation of a circle with center at 0, 0 and radius r. R is your radius. Again, that is your point x comma y. So these are both with the center at 0, 0. Now let's see, what would this look like if the center is not at 0, 0? I want you guys to try right now. Can you write the equation of this circle using the definition of a circle like we did above here, but now the center is not 0, 0. We have a different center. Pause the video right now as you try this on your own. All right, we're going to try this together. Now, when I look at this, I can see a diameter more easily right here and here. So they intersect. The center looks like it would be at 2, 1. And the radius, if I just count this from here to here or here to here, would be 4. So now I have the point 2, 1. If I draw this to any point, x, y, on the graph of the circle, and the radius is 4, now we can use the distance formula to derive the equation for this circle. So the distance between those 2 points is 4. Distance is equal to the square root of change in x squared plus change in y squared. Again, just like before, I'm not going to write the equation with the radical. I will square both sides. We have 16 equals x minus 2 squared plus y minus 1 squared. When I rewrite this, I'm going to write it with my x first, then my y, and then equals 16. This would be my equation for this circle. And we just use the distance formula to derive that. We want to come up with an equation for any circle with the center anywhere with a radius of r. So we're going to use h and k. And you guys might have used h and k as you guys were doing transformations back in Algebra 1. That might be familiar to you. So now if we look at this picture, we have no idea where the center is. Let's throw h, k here. And our radius, we'll say here, is r. Here's the point x, y, but x, y could represent any point that is r units from the center. So I can rotate that around, and now I got my circle. So if we want to derive the equation here, well, I know that my radius center is h, k. Radius is r. So the distance between these 2 points is r. Distance is equal to the square root of your change in x coordinates squared plus your change in y coordinates squared. But again, I don't want to write this with the square root. I'm going to square both sides, and I'll get that r squared is equal to x minus h squared plus y minus k. Oh, there you go, k squared. And again, I like to write my x first. X minus h squared plus y minus k squared equals r squared. And we call this the standard form of a circle with center h, k and radius r. So everything we do for the rest of the day is going to be using this formula right here. So I might highlight that in pink because that's going to be important. That is something that you will have to memorize, which hopefully, since we kind of spent time deriving this equation, it won't be too bad to memorize. So now let's flip to the back. We want to use that formula to do these three problems. Example 1, I want you to have a center of 0, 0 and a radius of 6. For B, a center of negative 2, 3 and a radius of 3 root 2. And for C, a center of 0, negative 5 and a diameter of 10. Go ahead and pause the video right now and try these on your own. All right, now let's take a look at this. So the center is 0, 0. We have this equation, x minus h squared plus y minus k squared equals the radius squared. So this would be x minus 0 squared plus y minus 0 squared. We'll zoom in a little bit so you guys can see that better. Equals 6 squared. Well, this is just x squared plus y squared equals 6 squared is 36. Here's my equation for that circle. Over here, we would have x minus negative 2 squared plus y minus 3 squared equals 3 root 2 squared. Well, this just becomes x plus 2 squared plus y minus 3 squared equals, if I square this, this would be 9 times 2, or my final answer, x plus 2 squared plus y minus 3 squared equals 18. Oh, sorry, there you go. And then finally, the last one, we have a diameter of 10, which means if the diameter is 10, your radius is 5, so be careful of that. So we have x minus 0 squared plus y minus negative 3 squared equals, my radius is 5 squared. That just becomes x squared plus y plus 3 squared equals 25. And there's your final answer. So I can give you information and you can write the equation. I can also give you a graph and have you write the equation as well. On your own right now, go ahead and write the equation of this graph, or of each of these graphs. Pause the video as you work on this. All right, as we look at this one, the center here is 0, 0. The radius is 3, so our equation, x squared plus y squared equals 9. For the next one, our center right here is 4, 3. This one, the radius is 2. So we have x minus 4 squared plus y minus 3 squared equals 2 squared is 4. And then finally over here, this one's a little trickier to find the center. The center is actually at 1, negative 1. The radius here, 1, 2, 3, 4, 5. So when I write my equation, x minus 1 squared plus y plus 1 squared equals 5 squared is 25. Now I'm going to keep asking you for equations of circles, but now I'm giving you a different piece of information. So let's look at example 3. Example 3 says the point 8, negative 1 is on a circle with the center at 4, 2. And I want you to write the standard equation of the circle. Take some time right now and work in your group and try and figure out what the equation would be. All right, so when I do this problem, I'm going to just do a little visual. I think it's helpful. If we look at this, 8, negative 1, 8, negative 1 is right about here. 4, 2 is here. This is your center. I'm going to put a little C next to it so we know it's our center. We know that this point is on the circle. So that means that this guy right here is our radius. So if I swivel this around every other point that has that same radius, then I will have my circle. Now, in order to write the equation of the circle, I need two things. I need the center and I need the radius. Well, we have the center, but now we need to find the radius. Well, if we have the center and a point on the circle, we can use those two coordinates to find the distance between them, and that will give us our radius. So our radius is going to be equal to the square root of 8 minus 4 squared plus negative 1 minus 2 squared. square root of 4 squared plus negative 3 squared, square root of 16 plus 9, square root of 25, or our radius is 5. So now we have a center at 4, 2. We have a radius of 5, and now I can write my equation. X minus 4 squared plus y minus 2 squared equals my radius squared. All right. For the next one, I'm now going to give you an equation, and you are going to graph it. So for A, the equation is x minus 2 squared plus y plus 3 squared equals 16. Go ahead and try A on your own and think through, what does the equation give me and how am I going to graph from that? Go ahead and pause the video as you work on this. All right, when I graph this, I look at this. I know that I need the center. Well, the center is x minus 8. So I'm thinking to myself, what am I subtracting from x? I'm subtracting 2. In other words, it's the opposite sign that I see here. So the center will be at 2 comma, again, the opposite sign I see here, negative 3. And this right here is r squared. So r squared is 16, which means that r is 4. So I have my radius and this point. So I can go over here. I can go to the point 2, negative 3. Make sure you realize we're going by 2's on the x and y axis. And the radius is 4. So I'll just go 4 to the right, 4 down, 4 to the left, and 4 up. And I will do my best to draw a beautiful circle. All right, that's a good circle. There's my circle. For B, let's graph the equation. X plus 2 squared plus y minus 1 squared equals 9. Go ahead and graph this equation on your own right now and pause the video. Now that you've tried this on your own, let's take a look at this. The center for this equation would be negative 2 comma 1. The radius, well, if this is r squared, then the radius must be 3. So I plot the point negative 2 comma 1. My radius is 3, so I'm going to go 3 to the right, 3 down, 3 to the left, and 3 up. And again, do my best to draw a pretty circle. Oh, looking good again. There you go. So if I give you an equation, we can graph it. The last problem is interesting. It's applying the use for these circles. So, example 5 says, you bury a time capsule and use a grid to write directions for finding it. Use the following measurements to find a burial location of the time capsule. So you have 3 different pieces here. 1, 2, 3. The first is that the capsule is about 11 feet from the oak tree at 0, 0. The second one is the capsule is 8 feet from the flagpole where B is 0, 8. And finally, the capsule is 4 feet from the mailbox at negative 12, 8. There's a lot of ways to do this. I'd like you guys to take some time right now and try this on your own. Go ahead and pause the video as you attempt this problem on your own. All right, so one way, and maybe the easiest way to do this is graphically. If we look at the graph, if the oak tree is at 0, 0, that's A, and we're 11 feet from it, so that's 4, 8. That would be 12, so 11 would be a little less than that all around. I draw this circle. There we go. So it's got to be somewhere on the circle if we're 11 feet from A. We also know that it's 8 feet from the flagpole at 0, 8. So 0, 8 would be right here. That's B. So 8 feet from there, well, this would be 8, 8, 8, and 8. So not only does it have to be 11 feet from A, it has to be 8 feet from B, which means there are only two possibilities right now that are both 11 feet from A and 8 feet from B, and that would be at these 2 points. So we've narrowed it down to 2 points. Now we have to use this last piece of information, the fact that the capsule is 4 feet from the mailbox at negative 12, comma 8. So negative 12, comma 8. That would be C. We are 4 feet from there, so we'll go 4, 4, 4, and 4. It must be this point right here. So the coordinates of that would be negative 8, comma 8. That would be the location. If you want to try an Algebra 2 skill, you could write an equation for each one of these circles. Those equations would be x squared plus y squared equals 21. X squared plus y minus 8 squared equals 64. X plus 12 squared plus y minus 8 squared equals 16. And you can solve this system of equations algebraically, because when you solve a system, you're really just finding the point of intersection of all of those equations. This is a little tricky. If you want to try this, I recommend doing elimination. Well, you could do elimination or substitution, but when you do that, you should get negative 8, comma 8 is the only solution for that system. Nice job.